I hope you can see my presentation. You can send some emojis, so I know you guys are here. So as Teza said, my name is Shahar. I work at DevOps consultant and architect. I previously worked at some big and small companies, startups and big tech and corporates, and I've seen a lot of configuration challenges, and I wanted to solve them with Protoconf. I just want to say that when I applied for this talk, it was over a year ago, and with times I forgot what I wanted to say in this presentation. So I asked ChatGPT why would the gRPC community would be interested in this talk, and this is what ChatGPT had to say. That you guys are going to care about centralized config management and how to unify all your configs under a single system. Dynamic configuration updates that will happen without the need to restart the application to improve their reliability and efficiency. Type safety in configuration, because Protoconf uses protocol buffers as the type system for configuration. It doesn't matter what language you use, you get type safety for your configurations, and you never get a string where it needs to be a Boolean or whatever. So there's less risk for you loading new configuration. It's compatible with gRPC because it was built for gRPC, application built with gRPC. And since it uses Git, you get configuration observability and history of what configuration changed and when. So I want to talk about all of this, but first I want to give a brief history of configuration management and how we got here. This is a condensed version of a longer talk that I did. So I just gave the last took the last slide. So the first generation of configuration management started in the 90s with CF Engine that introduced the declarative versus imperative approach. Before CF Engine, all Unix machines were configured by shell scripts. So if the shell script failed for some reason, it would have to continue from where it stopped, because you might don't want to delete again something that you just created. So CF Engine introduced of the declarative way of configuration with an eventually consistent. Eventually, the system will get to the state that you want, and based on the promise that what you described want to happen will eventually happen on the system. Second generation with Puppet and Chef comes in the early 90s. Early 2000s, where more hyperscalers started to come out. We started to see Chef and Puppet managing hundreds and tens of thousands of servers with a better syntax than CF Engine, with better code base architecture and better server client architecture that allowed various things and more features, and also reports on what's going on in the system. But then we entered into the cloud with EC2, and we started to see ephemeral instances, either by with spot instances or with dynamic auto-scaling, and we needed a fix for that. So Ansible and SaltStack introduced with two different approaches. Ansible cared about the provisioning and therefore knew all the systems in the environment, and Salt had a better subscription approach and discovery service for machines. So Salt could know the machines that are coming and going. And then we entered into the era of containers, and we started to see tools like Kubernetes and Helm and Terraform for SaaS services. But eventually, this is all software. And what I think is that we need to talk about how software is being configured and managed. And if we go from the software back to the system, the SaaS, the cloud, all of this, it's eventually software. So let's talk about the difference between what software wants and what human wants. Software wants static data for configuration, JSON in this case, but maybe even just binary blob. If it can, it will be easier for it to parse and safer. And human wants to write code. Human wants to write logic and functions that will help him write better configuration with less hassle. I took this quote from the SRE workbook. The quality of human-computer interface of a system configuration impacts an organization's ability to run that system reliably. This is from Google SRE workbook. I think it's a big deal. I think it's one of the fundamentals of running a reliable system. So with everything I learned about configuration, I decided to write Protoconf. It's heavily inspired by a tool called Configurator that runs within Meta or Facebook. It doesn't matter how you want to call it. But Configurator is basically in charge of all configuration changes, software configuration changes at Facebook. It comes from, it configures the load balancers, it configures the monitoring system, it configures all the software that runs inside Meta. So Protoconf have a few stages for the config lifecycle. We first want to compose the config. We want to validate that the config is correct. Then we want to deliver it to production and consume it by the software. So Protoconf deals with all of these four pillars. So when we compose a config, we first want to define the structure of the configuration, and we do it with protobuf. Why? So we can then compile it to whatever language we want, and the configuration that was compiled and composed by the Protoconf compiler will be easy to read from our app. Then we write the code and we compile the config. Let's see how it's actually happened in real life. So first, we define the structure. As I said, this is a pretty simple config with a integer of connection timeout, and we have a nested struct here, so we can do really complex configuration just by using protobuf system. Then we use the Starlark language, which is pretty much like Python. If you know Python, it will be easy for you to use. The reason we use Starlark is that because it's a limited version of Python, and Starlock doesn't have access to sockets and to files, so it's guaranteed that whenever you run the code, it will always produce the same output. Doesn't matter if you run it on your own computer or somewhere else. And after you compile the config, you'll see you'll get a JSON representation of the configuration, and now you can continue to validate your code. So we talked about composing. Now let's talk about validating. So the first thing Protoconf introduced for validation is the ability to write validation code, just like unit tests. You write a code that says, okay, this config produced is okay or not okay. And if it's not okay, it will never be written out. So you don't risk creating a bad, an invalid configuration. We'll see in a minute how it looks like. In the future, I want to support the validate proto standard, so it will be easier to just write inline rules inside the proto files. Currently, this is the way to do it. And after compiling and before we deliver it to production, we can run the software locally against the configuration. And after we feel we're ready, we push it to GitHub or GitLab, and we can just run a standard review both for the code and for the actual config before we ship it to everywhere. So this is how it looks like when we add validation. In this example, we just make sure that the connection timeout is higher than 3 or higher. And if not, we'll get a compilation error and we'll never write out the config. After we have the config, we can run the Protoconf agent locally and connect to it with our app. We will see that in the consuming part. So this is how we validate our config. So the next thing to do is to deliver it. And we have some keys to delivering. It needs to be fast. We want to deploy in seconds and not in minutes, because if we have fast delivery, we also have fast rollback. So the fastest we deliver the change, the fastest we can do a rollback to a change, and if something goes wrong, we can always roll back the change. It needs to be safe. We want to minimize the blood radius. If we have something like a single point of failure in the configuration delivery pipeline, then we might be doomed. It needs to be simple, so every organization can use their own strategy, and it is as simple as just run protoconf insert with the path to the root of our configs and the path of the configs that we want to load. This is the suggested deployment model. So after everything was merged to main, we will run a protoconf insert hook that will insert our configuration changes into console or etcd or Zookeeper. These are the supported key value storage that we currently support. They are all battle tested software, so you can trust it. And then the agent detects the changes on the key value store and can stream the config change to the application through gRPC. So this is the delivering, and now for the consuming. So this is all you need in order to consume a Protoconf config. You just compile this service to your language, and you can use it from your code. Just connect to the Protoconf agent, which runs either on your local machine or as a sidecar to your container, whatever you choose. You initialize the configuration that you have. You can have default values when you initialize the configuration, and then you just subscribe for the configuration. And every time there's a new config change, you can just unpack the config to the previous config instance and continue to read from it. I just want to say that because we're using gRPC, we can replace everything in this pillar. You don't have to use the Protoconf compiler and Starlock in order to compose the configs, because if you just comply with the protobuf schema, you can generate it from JavaScript or Ruby or whatever language you like the configuration to be done. And then you can also introduce your own validating process before you deliver everything. And since the gRPC definition of the agent, you can replace the delivery model as well. In fact, when I talked with a friend about it, that maybe people will be afraid to use the agent in production. He said, well, the agent is so simple that you can basically rewrite it in Rust, and this is what he did. He wrote a Rust version of the Protoconf agent and gave it to me as a birthday gift. I never released it because it was all used nightly features, but now they're probably merging production into the streamline, and maybe I should revisit that. And then, as long as your app uses Protoconf to consume the configuration, you can use whatever agent you want. But there's one more thing that I wanted to talk about. Up until now, we discussed how the human interacts with the machine when it comes to configuration management. But maybe you want a machine to change configurations as well. Maybe you want to change the log level from a portal, or maybe you want to make configuration changes based on telemetric information. So I want to also show you the mutation RPC. This is the mutation RPC. You can just connect to the mutation server and alter the configs. When we look at the code in the upper part is how you connect and make an RPC change through Protoconf, and down just how you load the config into the Starlock code, and then from there you can do whatever you want to do. And this is how it looks like. Just from your application server, you can make the RPC to the mutation RPC. The mutation RPC will recompile everything and will push it back to Git, and all the configuration will be streamlined into your applications. So as I said, it can be part of the CI, it can be part of the monitoring system, or you can make user interfaces for less technical stuff who needs to control the configuration of the applications. We need help. First, we need to get from 0 production users to 1, and then more. So if you're interested in using it, please approach me, and I can see how can I support you with that. I need help writing helpers in various languages, so it will be easier for people to use Protoconf. Maintaining the code base, of course, writing documentation and examples. And if you want to join and steering the committee for the project, you're more than welcome. If you want to learn more, this is our doc site. Please star us on GitHub and show love to us. You're welcome to join on our Discord. I'm hanging there all the time. And follow us on Twitter. Thank you very much.